Hey everybody, my name is Ankit Singh, student of BE Computer Science and Engineering, and today we are going to discuss about entity relation diagram, which is from the subject database management system. So before going to the entity relation diagram, first we should know about what is data, information, and database. So actually data is collection of raw facts, and when we process that data in some particular order, it is known as an information. And as we all know that apart from calculations and everything, our computer's main feature is to store the data. So our computer stores the data in form of related data form. And that storage of the data in related form, it is known as database. So there are many ways by which our system can store the data, like centralized database systems and distributed database. In centralized database system, actually the data is stored at one server like this. There will be only one server and there will be one path by which the person is sending requests to the server and retrieving the data. So when least number of people is requesting to the same data or at the server, it is very good. Okay, there is no issue. But when high number of requests is coming, so we can see that this path gets blocked. So this condition is known as bottleneck condition. So and this is very cautious in the terms of networking, because when these conditions arise, we see that some errors in our systems, like server is down, try again later. So to avoid this disadvantage of centralized database system, we use distributed database system, in which data is not stored at only one place. In spite of that, we store the data at multiple places, and these data are interrelated by each other. It seems like they are distinct to each other, but they are not. They are related by some of the methods, or by entities. So a distributed database is a collection of multiple interconnected databases which are spread physically across the various locations that communicate via our computer networks. A distributed database management system manages the distributed data in a manner so that it appears as one single database to the users. Actually, they are distinct. It seems to be distinct, but they are not. It appears to be only one single database or single table. So there are various database models which came into the existence, like relational database model, semi-structured data model, entity relationship data model, and object-based data model. So our main topic is only entity relationship data models. So entity relationship model, or ER diagrams. ER model stands for entity relationship model. This model is used to define the data elements and relationship for a specified system. Actually, it is used to define one relation for entire system, like for college database or employee database, or some other car sale manufacturing database, like that only. We can use this ER diagram for that. It develops a conceptual design for the database. Actually, we before designing one database system, we use this AR diagram, and it also develops a very simple and easy to design view of the database. Actually, using this ER diagram, we can create one view. View is nothing but some virtual tables in our mind. Okay, so these are the name and phone number and Aadhaar number can belong to only one table of the student, like that. And in ER modeling, the database structure is portrayed as a diagram called an entity relationship diagram. And this database structure is that is portrayed in this entire uh, system. It is known as entity relationship diagram. So here is an example of that entity relationship diagram, where there is one entity which is named as student, and that is nothing but, guys, it's just a table, which we know in ER diagram we call it as table. And a student table can contain many attributes or the columns, such as student name, his address, his phone number, his ID, his age, his father's and mother's name, and all. So here is some example, like his name, his address, his ID, his age. These are the information which we store in a database of a student. So here are the component of ER diagram. First, we have entity, attributes, and relations. So entities are in two types, like weak entities and strong entities. We will see in later slides what are they. And attributes are nothing but that columns. So how they are defined in this, there are some key attributes, there are some composite, multi-valued and derived attributes, and relations. How one entity or table are related to other table. Like it can be considered by one way or one to many or many to one or one many to many. And we are going to see about that in the later slides. So symbols and notations for ER diagram. Since it's a pictorial representation of that database form, so there are some certain rules and regulations which are set by the authors, which we use to define and which used to define some entities or composite attributes and all in this diagram. So first entity set is represented by rectangular box in which we have two things like strong entities and weak entities. So strong entities are defined by only singular rectangular box, and weak entities are represented by double rectangular box. So there are simple attributes which are represented by this uh, single oval or elliptical shape, and composite attributes are consist of two smaller attributes with the help with combine of which this single attribute is being made, and this single valued attribute. So it's only this single value attribute is also defined by only one single oval only, and multi-valued attributes are defined by double oval, and that derived attributes are defined by dotted ovals, and null attributes in it's empty, so it's nothing. And relationship. So strong relationship are defined by one diagonal or rhombus shape, and weak relationship is defined by double rhombus shape. And then notation for relations. So relation is nothing but how one table or entity is related by other. So there are mainly four types of relations are given, like one to one to many, and many to many. So there are certain examples which are given in the later slides. For example, for one-to-one relation, we can say that one Aadhaar number is belongs to only one person, and one person can only have only one Aadhaar number. So like that, we have certain examples in the upcoming slides. So entity is an object or component of the data. As I told, it's just a table or a object of that diagram or data, and it is represented as rectangular in ER diagram. Its pictorial representation is in rectangular form. For example, employee and department are two entities which are related by this works for a relation. So first we have weak entities. Weak entity are that depends on another. One entity which depends on other. That is known as weak entities. The weak entity doesn't contain any key attribute of its own, and the weak entity is represented by double rectangle, as I told. So this installment here example is a weak entity. On the other hand, strong entities are that independent and individual. They have their own key value, key attribute values. They are usually used as a primary key, but here we can not use it as primary key. We use partial key in weak entities. And we can take some another example like employee and its dependents. So the dependents, for dependent we cannot give any other employee SSN numbers. We use one employee SSN number along with that name of the dependent together and make it one primary key for identification of that dependent. Second one here is an attribute. Attribute is nothing but that headings or that columns which which is contained inside one table. So a student can contain his name, his age, his phone number, his ID, his Aadhaar number and all. So here four are only given: ID, phone number, names, and age. So attribute is used to describe the property of an entity. Ellipse is the used to represent the attribute, as I told before. So here is a classification of attributes. First is key attribute. The key attribute is used to represent the main characteristic of an entity. It represents a primary key. The key attribute is represented by an ellipse with a text underline. Actually, the thing we used to say that the related data and related entities. So to you relate one table or entity to another, we use some constraints or some attributes. So that primary key is one of the most important attribute which is used to relate one table with another. So, and we usually make those attributes as primary key which are not repeated. For example, ID number or Aadhaar number and all. So here in student entity, the ID is only one primary key attribute. So the composite attributes. An attribute that is composed of many other attributes is known as composite attribute. The composite attribute is represented by an ellipse, and those ellipses are connected with another ellipse. Actually, composite attributes are those which can be further divided into the other attributes also. For example, name here is it's in first name, middle initial, and last name. Actually, a person's name is Arun Kumar Singh. So we can further divide his name in three other attributes also, like first name, middle initials, and last name. First name could be Arun, middle initial is Kumar, and last name is Singh. And we can also combine it and save it only in one attribute, which is name. Its name is name only. The third one here is multi-valued attribute. An attribute can have more than one value. These attributes are also known as multi-valued attributes. The double oval is used to represent the multi-valued attributes. So some of the attributes which can be again and again repeated with that are known as multi-valued attributes. First is primary key, which cannot be repeated again, and here it is multi-valued attribute. For example, phone number. A student can have three or four phone or four SIMs, so he can have four different numbers in that four student entity table. So it's an multi-valued attribute. And another is derived attribute. So derived attribute is nothing but the attribute value is derived from another attribute. For example, here age is an derived attribute. The age, his age could be 21, 22, 23. That we can derive it using this date of birth. We can use the date of birth condition. When we know that his date, month, and year, we can calculate it and find his age. So it's a derived attribute. So third one is relationship. So how one entity or table is related with another. It is known as a relationship. So teacher is related to a student by the relation teaches. So a teacher teaches a student. And some other example are an employee works for a department. A student is studying in computer science department. So student and department relation is studying like that. So here there are mainly basically four types of relations: one-to-one relation, one-to-many relation, many-to-one relation, and many-to-many relation. So first is one-to-one relation, where one of the entity is related to another entity using only one relation. Like as I told, one person can only have one Aadhaar card number, and one Aadhaar card number belongs to only one person. As here example is given, like one female can be married to only one person, and one male can be married to only one female. So one to many relation. So one scientist can invent many inventions, can invent many of the things and many patents, but one of the invention which is made by him, it belongs to only one scientist only. Another scientist cannot make it again and say that I have made that. So many to one relation is just a vice versa of one to many relations. So one student can enroll in only one course. Like we student of computer science engineering, we have enrolled in only one course. But computer science engineering course can contain many number of students. many students are enrolled in that course. And many to many relations, like many number of employees can assign number of projects. Like one person can work on 4 projects, and a single project is done by 4 persons itself only. So here many to many relation is used. So here's the step how we can create an ER diagram. So first we should know about what are the entities in that ER diagram. Like if we are going to talk about college database, so there is staff member details, department details, and student details. What are all the courses which are taught in that? So these are the tables, entity tables which we have to make, and the relationship identification, how these tables are related to another. Like one staff member can belong to this department, like works for this department. One student is enrolled in this course. So a staff member can also be a mentor of one student. So these are the relations, how one of the tables or entities are related to one another. And cardinality identification. Cardinality is nothing but that how many numbers in that entity is related to another entity, like one to one, many to one, one to many, and many to many, how it is relation. And identifying the attributes. What are all the columns and tables which columns which are contained inside the attributes? Like an student table can contain his name, USN, and his phone number and all. And staff members can also contain their unique identification code, SSN numbers, their names and their phone numbers and all. And create the ERD, means nothing but ER diagram. So these are the 5 steps by using which we can make one ER diagram. So here is an example of an ER model of a student database. So here is one student table which contains his date of birth, phone number, student ID, student name. So here everything is given, like a student name is a composite attribute because he can contain his first name, middle initials, and last name. Student ID is a primary key, it is given here. And phone number, one student can have 3 phone numbers also, so it's an multi-valued attribute. And date of birth is a simple attribute, and age is a derived attribute. It can be calculated using date of birth. And this student entity is related to another entity which is named as book by using read relations. It's a relation, and it's, I guess it's one-to-one relation only, one to many and anyone. And a book entity can also contain one attribute, this key attribute. And authors are the multi-valued attribute, as one author can also write the book, but there are multiple authors which can write the single book also. And book name is a single attribute, and his price is also a single attribute. So it's just an example of ER model diagram. So thank you guys, we are going to meet in next video.